Freshies! Welcome back to another episode of Learning Mathematics here at DepEd TV. I am Teacher Belle, ang iyong kaduo sa Math 7. This is a new day for fun and exciting learning in mathematics. Together, let's be Math Tibay, Math Talino, and Math Galing!
Exciting, discover new topics that are amazing. You can surely enjoy this thing. Show the skills that you have inside. By solving problems, yes, you'll make it right. Embrace new knowledge, isn't it fun? Come on, let's learn something now. Numbers can also be your friend. Just sit down, focus, and listen. Have you heard of sets, integers, and absolute value? If not, here will help you. Be math galing, be math galing. You can surely enjoy this thing. La 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 la. Be math galing, be math galing. You can surely enjoy this thing.
Prepare your pen and your self-learning module and let us navigate a fascinating concept useful in both science and math, that of standard and scientific notations. Let us start today's episode by pointing out why scientific notation is quite worthwhile to learn, not only to become well-versed in calculation, but also in presenting results of experiments or studies concisely and easy to compare with existing figures or data. Did you know that a googol is the number 1 followed by 100 zeros, or in scientific notation is 1 times 10 raised to 100? The term was coined in 1920 by a 9-year-old nephew of Dr. Edward Kastner. A certain physics professor in Nottingham, England, claims that the number of particles out there, that is the number of protons and electrons in the observable universe, is 3.28 times 10 raised to 80. The diameter of a red blood cell is about 84 millionths of a meter, or technically speaking, a typical human red blood cell's diameter is 8 micrometers. Such small specimens can only be seen if you are looking into a light microscope. These microscopes are able to magnify objects up to about 1,000 times. Amazing, isn't it? Before we proceed to the main lesson on scientific notation and standard notation, let us check how skilled you already are on multiplying numbers by the powers of 10. You have 3 questions to answer. For each question, you will be given 3 seconds. So let us begin with number 1. Multiply 7 and 331 thousandths by 100. Timer! If you got 733.1 as the product, nice work! 7 and 331 thousandths times 100 is equal to 733.1. Number 2. What is 125 thousandths times 10,000? Timer! Great! The product of 125 thousandths and 10,000 is 1,250. Third question. What is the product of 1 times 10 raised to 6? Timer! If you answered 1 million, then you got it right. 1 times 10 to the 6th power is equal to 1 million. So we are done answering an assessment of your prior skill, which is more of multiplying numbers by powers of 10. Were you able to answer all the questions correctly? If not, no need to worry, because I am here to help you sharpen your skills related to scientific notations. Scientific notation is a special way of writing numbers. They are especially utilized to have a simpler way of expressing exceedingly large or small numbers. Consider a situation which emphasizes how important expressing a quantity accurately is. If a dosage of 2.04 times 10 raised to negative 2 gram is incorrectly written as 2.04 times 10 raised to 2 gram in a prescription, how many times larger would the second number be? When taking scientific measurements, it is important to be accurate because a slight difference may give us a different meaning. Having a good number sense and being analytical is crucial, not only in health sciences, but also in construction. Now that I have explained why scientific notation is essential to most fields related to disciplines that we come across within day-to-day living, let's take a look at an example of how to express numbers involving decimal in its equivalent forms. Now, we shall be writing numbers in scientific notation. As mentioned earlier, scientific notation simplifies the way we write exceedingly large or also extremely small numbers. In a nutshell, we can therefore say that a notation of this form is composed of a number part called coefficient, and appended to it is a multiplier of base 10. Let's consider one of the numbers I gave earlier, 4,900,000,000, or 4.9 times 10 raised to 9. 4.9 is the coefficient and 10 raised to 9, which is the power of 10. The coefficient c is a number greater than or equal to 1 but less than 10. On the other hand, the notation times 10 to a power is an indicator of where the decimal point should be if it's to be rewritten again as a standard number. Now, how do we write numbers into its scientific notation? Note that in scientific notation, moving the decimal point to the left or to the right will depend on whether 10 has a negative or a positive exponent respectively. When the number is 10 or greater, the decimal point has to move to the left, and the exponent of 10 is positive. When the number is less than 1, the decimal point has to move to the right. Thus, the exponent of 10 is negative. Let us convert the following in scientific notation. Letter A, 5 ten-thousandths. Letter B, 72,290,000,000. To figure out the power of 10, think, how many decimal places do I move the decimal point so the coefficient c is within the range greater than or equal to 1 but less than 10? Using our first example, it is a number less than 1, so we shall move the decimal point 4 decimal places to the right. So it shall have a coefficient 5. Thus, the value of c is 5, and the exponent we will use is negative 4. Our final answer for the first example should be 5 times 10 raised to negative 4.
For letter B, we need to write 72,290,000,000 in scientific notation.
Since the number is greater than 1 and the decimal point is at the far right of the digit 7, we expect that we shall move the decimal point to the left.
Thus, the coefficient is 7.229 and the exponent of 10 is 10.
since the decimal point was moved 10 decimal places to the left.
7.294 times 10 raised to 10. But what if we start out with numbers in scientific notation and we want to convert them in its regular or standard form? Let us have converting from scientific notation to standard notation. For our first example, let us convert 3.456 times 10 raised to 4 in standard notation. This means we just need to multiply 3.456 to 10 4 times, or simply put, 3.456 times 10,000, since 10 to the 4th power is 10,000. Or since you are multiplying a power of 10 that is positive, meaning its order of magnitude must be bigger than the given coefficient c. We just move the decimal point appropriately. This means we need to shift it in the direction that will make the number bigger. That is, we shift the decimal point 4 places to the right. Thus, the number 3.456 times 10 raised to 4 is equal to 34,560. Now let us have an example wherein 10 has a negative exponent. Let us rewrite the number shown in your screen back to its standard form. Our multiplier is 10 raised to negative 4. Multiplying by the quantity 10 raised to negative 4 is the same as dividing by 10,000. Thus, the multiplication statement 3.456 times 1 10,000ths. And we get the answer 0.00003456. Or as we did earlier, but this time in the opposite direction when shifting the decimal point. This means we will move the decimal point 4 places to the left. Therefore, 3.456 times 10 raised to negative 4 is equal to 0.00003456. To verify whether you have learned the required learning competency, which is to write numbers in scientific notation and vice versa, let us now answer the short activity that I prepared for you. Ready? Let's start! Select the letter that corresponds to the correct answer. Number 1. Which of the following represents 6 and 7/10 times 10 raised to negative 2 in standard notation? Letter A, 0.0067. Letter B, 0.067. Letter C, 670. Or letter D, 6,700. Second question. The planet Mercury has an estimated distance of 1 and 3500ths times 10 raised to the power of 8. How will you express this distance of Mercury from the Sun in standard form? Letter A, 13,500 miles. Letter B, 1,350,000 miles. Letter C, 13,500,000 miles. And letter D, 135 million miles. Number 3. The speed of light is 186,000 miles per second, or about 671 million miles per hour. How would you express these numbers in scientific notation? Letter A, 186 times 10 raised to 5, 671 times 10 raised to the power of 8. Letter B, 1.8 times 10 cubed. 6.7 times 10 raised to the 6th power. Letter C. 1.86 times 10 raised to 5. 6.71 times 10 raised to the power of 8. Letter D. 1.086 times 10 raised to 5. 6.701 times 10 raised to the power of 8. Number 4. The radius of a hydrogen atom is 2.5 times 10 raised to negative 8 millimeters. What is the radius of the hydrogen atom if it is to be written in standard notation? Letter A. 2 millions. Letter B. 2,500 millions. Letter C. 25 billions. Or letter D. 2,500 billions. Number 5. According to history, the first pandemic was the Spanish flu, also known as the 1918 flu pandemic. The recorded death due to this, considered as the deadliest pandemic of the 20th century, is about 10 million people. What is 10 million in scientific notation? Letter A. 1 times 10 to the 5th. Letter B. 1 times 10 to the 6th. Letter C. 1 times 10 to the 7th. Or letter D. 2 times 10 raised to the power of 8. Timer! We have come to this part. Let us check your test. The correct answers are, for number 1, letter B. We need to move the decimal point 2 places to the left since the exponent is negative 2. So that will be equal to 0.067 in standard notation. Number 2, letter D. Since the exponent of 10 is positive 8, we will move the decimal point 8 places to the right. So that is equal to 135 million. Number 3. The answer here is letter C. Since the given numbers are greater than 1, we shall move the decimal place to the left and the exponent should be positive. The speed of light is 1.86 times 10 raised to 5 miles per second, while its speed in miles per second is 6.71 times 10 raised to the power of 8. For the fourth question, the correct standard notation is the one in letter C, which is 25 billions. Here, we will move the decimal point 8 places to the left since the sign of the exponent is negative. For our last question, 10 million has 7 zeros. So we can multiply 1 to 10 raised to the power of 7. The correct answer is letter C, 1 times 10 raised to the power of 7. How's your score? I'm quite sure you got a high score. I am rooting for you because for sure you have proven again that you are Math Galing! For our last task today, let us summarize the procedure in writing numbers in scientific notation or vice versa, using a section of your self-learning module. Complete the following statements. Choose your answer from the box that best completes what is being stated in the statements that follow. Number 1. Blank is a way of writing very small or very large numbers. Number 2. Scientific notation is composed of a number multiplied by a blank. Number 3. If we are given a number in standard form and we need to express it to its scientific notation, when the decimal is moved towards the left, the exponent of 10 should be blank. Number 4. If we are given a number in standard form and we need to express it to its scientific notation, when the decimal is moved towards the right, the count for the exponent of 10 should be blank. Number 1. Scientific notation. Number 2. Power of 10. Number 3. Positive. And number 4. Negative. That's it for today, but learning does not end here. In our next episode, we are going to explore a lesson that is actually the culminating part of what we have learned about real numbers. Again, this is Teacher Belle, ang iyong kaduo sa Math 7. I hope we help you become math tibay, math talino, and math galing!